Hello everyone, welcome to the video. In this tutorial I will explain how to use buttons and LEDs on the STM32 discovery board using registers. Let's get started. Firstly, we need to create a new project. You should choose your own STM board or MCU when you're creating the project. I choose the discovery board because I used the discovery board in this tutorial. The choice of the board or MCU is critical because most likely the ports and port lines you need to use will be different from mine. In the STM32 discovery board, the LEDs are connected to lines 12, 13, 14 and 15 of port D, while the button is connected to line 0 of port A. Therefore, I will make the configurations according to these connections. The AHP1 register is responsible for the ports. We configure the clock settings of the relevant ports in this register. We are grouping the bits in sets of 4 because each hexadecimal digit is responded by 4 bits. If you remember, we were using port D for the LEDs and for the button we were using the port A. Therefore, we should set the 0th and 3rd bits of the register to 1. This way we enable port A and D. The other bits can remain unchanged. In binary, the 3rd bit represents 2 to the power of 3, which is 8, and the 0th bit represents 2 to the power of 0, which is 1. Therefore, setting the 3rd and 0th bits to 1 corresponds to 8 plus 1 equals 9. So if you write 9 in hexadecimal, it activates port A and D. For example, if I want to use port B and port C, I need to write 1 to the 1st and 2nd bits. So I need to write 6 in hexadecimal. We will apply these operations for each register, so keep that in mind. I deactivated the GPIO-in function because I am manually configuring the ports. After that, I am activating the ports. We will use the mod register, output data register and input data register for this tutorial. Firstly, we are starting with the mod register. Thanks to this register, we can define the port lines as input or output. If you remember, lines 12, 13, 14 and 15 of port lines are connected with LEDs. So, module 12, module 13, module 14 and module 15 should be set to output mode. If I write the 1 to the 24th, 26th, 28th and 30th bits, they will be set to output. Now that we have set up the output ports, let's look at the input port. If you remember, our button was connected to 0th line of port A, so module 0 should be set to input mode. If you notice, in the reset state all the lines are set to 0, so they are all defined as input initially. But for the sake of example, I will define only the 0th line as input. If I write the 3 to the module 0 and toggle all the other bits, I can define only the 0th lines as input. After making the necessary adjustment in the mod register, we can then convert the settings into code. Our next register is input data register. This register, like the mod register, is also 32 bits. However, the last 16 bits are reserved, meaning we cannot use them. We will read the data from the button using the input data register. The button was connected to 0th line. Therefore, we should use the 0th bit. Our last register is the output data register. This register is almost the same as the input data register. We will control our LEDs using the output data register. Our LEDs are connected to lines 12, 13, 14 and 15. Therefore, we should use it with the 12th, 13th, 14th and 15th bits. I write 1 to the relevant bits to turn on the LEDs. We have completed all the configurations in the registers. And now we can proceed to coding stage. I am writing the program so that every time I press the button, it will toggle the state of the LEDs. For your C suite to function correctly, you need to specify a debugging time after pressing the button. Otherwise, even with a single press of the button, it may appear as if you have pressed it 2 or 3 times. You can observe the difference by trying it out.